Here we want to solve this inequality, the absolute value of 2x minus 3 is greater than 7. So we want to graph the solution on the number line and express the solution in interval notation. Of course, the first thing we notice is not an equal sign here, right? It's an inequality. Okay, so the first thing we still should do is isolate the absolute value. Okay, so remember, anytime we have inequality, there's always two sides. Okay, but we should get the absolute value by itself on one side. So that means this 3, right, or this minus 3, we have to move over. Okay, so in this case, using the properties of equality, we should add 3 to both sides. Okay. So what do we end up with? We get the absolute value of 2x is greater than 10. Okay, so we've accomplished the first thing, right? We've got the absolute value by itself. But also the next step, right, is the key step here, right? Remember, the absolute value, there's always two parts to it. There's always the positive scenario and the negative scenario. Okay? And of course, you want to remember the golden rule with inequalities, right? Whenever we multiply by a negative, we have to flip the direction of the inequality. So what does that mean? It means that what are the two cases that arise from this? Well, it's 2x is greater than 10, right? So just as we see it, we haven't changed anything. The absolute value of the 2x is greater than 10. But what is the other case? The other case is, well, what if we're on the negative side of 0? Okay, so essentially we want to be negative 10 here, but because we're making this negative, essentially we're multiplying by negative 1. That means we have to switch the direction of the inequality. So we get 2x is less than negative 10. And we want to solve, right, these two inequalities. Okay, we call this a compound inequality. So let's go ahead, we'll divide this by 2, so we get x is greater than 5. And here when we divide by 2, we get x is less than negative 5. So we should be able to sketch the solution on the number line. Okay, so let's just do 0. I'm going to put the 5 here and the negative 5. Okay, how are we going to sketch this guy? X greater than 5. Well, first thing you notice is it's strictly greater than. It's not greater than or equal to. That means there's going to be an open circle, or you can do a parentheses here. But we want all values of x that are greater than 5. So that means we're going to go to the right. Okay? Because once we go to the right, all of the numbers are greater than 5. What about this? X less than negative 5. So we'll put an open circle at negative 5. But we want to express all the values of x that are less than negative 5. Well, less than means we go to the left, right? So we want to go this way. So this would be the solution on the number line. And then in interval notation, essentially, it gives you the range of values that are part of the solution, right? So the number line should actually tell us what the answer is in interval notation, right? This arrow goes, well, essentially, forever to the left, right? It goes all the way to negative infinity. So we're going to go from negative infinity up till negative 5, but because it's an open circle, we need a parentheses. And then we're going to combine that. That's called the union because we're dealing with intervals now, right? So the union with everything from 5 to infinity. Right? And then this would be the answer in interval notation. What does this answer mean? It means that any value within these two intervals, right? So any value between or less than negative 5 or greater than 5 is a solution to the original inequality.